Hey everyone, welcome back to another fun and exciting geometry class. Today we are going to be launching out into chapter number 2, and we are going to be talking about proofs and about deductive reasoning and all kinds of fun stuff like that. All right, if you go ahead and look down here at the screen, I've got the word theorem written. So let's start off with that. And I'm on page number 46 in your book, page number 46, chapter 2, lesson 1. A theorem is something that is not self-evident. At the end of the last chapter, the last lesson, we talked about axioms, we talked about postulates, and those things we said everybody believes those. Those are self-evident. That's true. You don't have to prove it. It is what it is. A theorem, on the other hand, is something that most people would probably think is true, but you have to prove it. You have to come up with some reasons why it's true. Maybe even some people wouldn't think it's true. Some people would think, no, that can't be true. Well, in a theorem, mathematicians, scientists, different things like that, they have to take things and they say, okay, this is a theory or this is a theorem. And now we have to prove that it is actually true. We have to set up some, maybe it's in science, we have to set up some experiments, we have to do some things, and we have to prove this is true. In math, we have to, we're going to talk about it today, but we have to use some reasoning, some logic, and we have to take some steps, and we have to say, okay, this is why this is true. And so that's what a theorem is, at least in geometry. Same thing really in science. All right, number 2. Not only are they not self-evident, but they must be proven by a chain of reasoning. In other words, you can't just say, oh, this is true because I think it's true. You have to say this is true because this, and because this, now that's true. So after it's proven, number 3 here, after you prove a theorem, in the future, you can use that theorem, and you don't have to reprove it. So let's say that 6 months from now, when we're doing algebra or when we're doing geometry, we don't have to reprove a theorem that we proved today. Because we proved it once, we're saying for the rest of the year, for the rest of time, then that theorem is proven. We don't have to go back and reprove and reprove and reprove. Okay, we can just take it, do it once, prove it, and then we can use it in the future. All right, deductive reasoning. It's what you can see here on the screen. It says truth about a statement is based on previously given truth. Okay, so what does that mean? If I say all 11th graders got an A on their test. Wouldn't that be nice? All 11th graders got an A on their test. And then I say, Bob is an 11th grader. Okay? Well, based on my previous statement about 11th graders, what do I know about Bob? Bob got an A on his test. That's right. Why? Because Bob is an 11th grader, and all of the 11th graders got an A on their test. Now, that's not really true. Okay, we know that all the 11th graders did not get an A on their test, but let's just pretend it's true. So that's what it means to deductively reason. Now, again, I talked about this a little bit a minute ago. Up until this point, you've not done a lot of this. Maybe some of your parents have even told you, you don't make any sense. Like, I don't get you. And sometimes you think about your parents, you don't make any sense. I don't get you. And here's what's happening. Your parents have come through this. Hopefully, they use logic. Maybe you say, I'm more logical than my parents. And maybe you are. But for the most part, young people, about that 12, 13, 14-year-old range are just starting to develop logic. Like, you can't tell a 2-year-old logically why to do or not do something. If you tell the 2-year-old, now don't play in the street because I don't want you to get the cars can hurt you, and they don't understand any of that. When the ball rolls into the street, the 2-year-old runs into the street to get the ball because the only thing they can think is, I got to get the ball. I was having fun with the ball. I want the ball. I need the ball. They're not thinking about everything else. That's why they need babysitters. That's why they need people to watch over them so that they don't make big mistakes, because they're not logical thinkers yet. And so usually by about the time 12, 13, 14-year-olds start to come around, now they can be the babysitters because now they're starting to logically think about things, and they're starting to think, I can't let that 2-year-old run out in the street. So that they're protecting the 2-year-old. And that's kind of what logic does for you. But if you think about it, you've only started to develop this. This is not something that you've really made solid in your lives. It's something that you're still working on, still developing, depending on your age that you're taking this class or watching this video. But most high school students are still working on developing their reasoning. All right. Well, so that's deductive reasoning. That's the whole concept there. And this is what geometry is going to teach you. Parts to a geometric formal demonstration. You see in your book on page number 46, a demonstrative geometric proof. This is what we're talking about. In geometry, we prove things to be true using logical steps based on previous information. So we learned some things about a circle. We learned some things about a triangle. We learned some things about quadrilaterals. We've learned several things already in Chapter 1. Now what we're going to do in Chapter 2 is we're going to go back to the information that we've already previously learned, and we're going to make logical deductions, and we're going to demonstrate that in the form of what's called a proof. There are 4 parts to this, and this is in your book down there in the bottom of page number 47. The first thing is the given. Somebody has to tell you some information. I had to tell you that all of the 11th graders got an A on their test. You didn't know that. You had no idea. I'm the one that graded the test, okay? So you didn't have that information. I had the information. I had to share the information with you. I had to give it to you. You had to learn it, okay? And so that's the given. This is the new information that the problem is giving you. So the problem gives you some information, and that is the step number 1. You're receiving given information. Number 2, the second thing that every proof has is it has a proof. This is where they want you to go. It's like a roadmap. Okay, so you start up here at the given and you have to find the proof. Okay, and so this is like a road that you take to get to that point where you know those mazes where you take and you try to figure out and you follow all the lines and you finally get to the end, you finally make it out. That's what a proof is. A proof is, or a geometric demonstration is that. You're starting here, that's the given, and then you're following the road to get to the exit. You're leaving. That's the proof. That's what you have to get to. And here's the neat thing. They give you the problem, they give you the proof, or they give you the given, and they give you the proof. They tell you where you're going. They say, okay, start here and go here. So we have to fill in the middle part. That's what we're trying to do. And that's what's called the analysis and the proof. The analysis is kind of the stuff that when you analyze something, you're like looking it over and you're trying to figure it out. In the analyze stage, this is where you're going to want to make a drawing. This is where you maybe brainstorm. You try to get all your thoughts and you try to put them down on paper. You try to draw what was given to you, and you're trying to think of ideas. That's in the analysis stage. You're analyzing. You're trying to figure out, what does this thing want from me? And then the last is the proof. This is where you actually have to take and you have to write this out. So all proofs must consist of statements that are proven by one and only one reason. So you have to go step by step. So every proof is multiple steps. So you have 1, statement. And then you have to have a reason for saying that. And then you'd have another statement. And then you'd have a reason for saying that. And then you'd have another statement and a reason for saying that. Some of these proofs might be 14, 15, 20 steps. Some of these proofs might be 3 or 4 steps. They're different. They're just different complexities and different amount of steps to get to the final. That's like, you know, some of the puzzles or the mazes that you do are very easy, and some of the mazes or the puzzles are very complex. It's the same thing here with geometric proofs. Let's look at it. Let's look at one here. Okay, so here's a statement. The statement is, all 4th grade boys have on blue shirts. Now, I'm telling you that. I'm giving you that information. This is what the problem is going to say to you. And every time the problem gives you information, you have to write it in the statement. And the reason is always the same. This is the given information. They gave it to me. Whatever they give you, write it down. Okay? So all 4th grade boys have on blue shirts. Okay, that's my given information. Now, Juan is in the 4th grade. Juan is in the 4th grade. How do I know that? Well, I didn't tell you. So maybe you did some investigation by yourself. Maybe you figured that out. Maybe you could say, I verified in class roster. So I went to the roster and I read Juan is in 4th grade. There he is. His name is in the 4th grade roster. Okay, so that's my reason. So here's my statement. Juan is in the 4th grade. How do you know that? How do you know Juan's in the 4th grade? Well, you have to have a reason. You can't just say Juan's in the 4th grade. You can't just make it up because he is. No, you can't say that. You have to come up with a reason. So you verified it in the class roster. Okay. So I would look at that. That makes sense to me. It's logical. Okay. Now, if you said something like, my brother told me. Well, who cares about your brother? Who knows if he knows what he's talking about? Maybe he just made it up. So you can't just throw anything you want into the reason. It has to be an actual reason that verifies your statement. All right, then the last one here is now we can say Juan has on a blue shirt. Well, how do we know that? Well, because all the 4th graders have on, all the 4th grade boys have on a blue shirt. And then we know that Juan is in the 4th grade. We might actually have to put one more in here. And you might have to go, you know, number 3, and we'll change this to number 4. And you might have to say Juan is a boy. Because, I mean, theoretically, you could be named Juan and be a girl. Okay? And, you know, you'd have to have a reason for that. Verified birth certificate. I don't know. Talk to Juan's mom. Okay, I don't know what you did, but you verified Juan as a boy. Okay, so you might want to do that too. But we'll just assume that's true, okay, that Juan is a boy. So number 3, Juan has on a blue shirt. We know that. Why? Because I could put here deductive reasoning. What does that mean? It means that I took previous information and I deduced from that a truth. Here's the truth. Juan has on a blue shirt. Now, that's not geometry, that's logic, but we are going to be using logic to do geometry. So we're going to be doing this using geometry, and we're going to be going through these steps and making proofs this year. So, all right. Well, I hope you enjoyed that. I know that was a lot. It's a lot to think about, but this is the rest of geometry right here. In a nutshell, this lesson described to you what we're going to be doing really till the end of the school year. All right. Well, we'll see you later. Hopefully you learned something today. Bye-bye.